Okay, so good morning for our prelim for week module number 1. So our subject is EE137 or Electrical Machine 2. So continuation ni siya sa inyuhang Electrical Machine 1 which is ang EE133. So for topic for our prelim, we have AC Machinery Fundamentals. So nabilong ang rotating magnetic field and magnetomotive force and flux distribution. And third is the induced voltage and induced torque in AC machine. For an objectives or outcome of this module is we will discuss the principle of AC machinery fundamentals, and number 2 is we need to analyze the machine power flows and losses. So alternator for our first topic. So unsa man ning alternator? So alternator is a machine for generating alternating EMF. So mao na siya ang ginatawag nga alternator. Alternating operate on the principle of electromagnetic induction. So alternator have armature winding and magnetic field. So take note nga ang armature is na ay armature winding and magnetic field. So alternators according to their construction are divided into the following two classifications. So sa atong alternator, we have two classification. So first we have revolving armature type. And second is we have revolving field type. So for our frequency of voltage in an alternator, so we have our formula. F is equal to P multiplies atong N divided by 120, where F is the frequency. So ang unit is in hertz and P is the number of poles and N is the speed of rotation. So ang unit ani is in revolution per minute or RPM. So let's have an example sa frequency of voltage. So we have here a 36 pole alternator is operated at 200 RPM. What frequency is generated? First, we need to write our given sa atong problem. So ang given, so naa siya P which is 36 poles, and we have also the N or the speed of rotation in RPM which is 200 RPM. So ang required sa problem is ang frequency. So therefore atong unknown we have F. So to solve, so formula we have F P multiplied sa N divided by 120. So our P is 36, our N is 200 RPM divided by 120. So our final answer will be, so calcu we have 60 Hertz. So this is our final answer. So let's proceed for generated voltage in an alternator. So naapoy formula for generated voltage. So we have here E is equal to 4.44 multiply sa F and in the and our angle phi or flux per pole. So take note nga ang E is the RMS voltage. So ang unit we have volts. And F is the frequency in hertz. And N is the number of turns in coil. And angle phi is the flux per pole in Weber. So, muna to ang unit. So let's have an example for this generated voltage. So first, we have solved the effective voltage in one phase of an alternator given the following particulars. So F is equal to 60 Hz, turn per phase is 240, flux per pole is 2.08 times 10 raised to 6 Maxwells. So naghatag na tao given. So again, i-write na to. So F is 60 Hz, N is 240, and our flux per pole or angle phi is 2.08 times 10 raised to 6. So formula, we have E is equal to 4.4 N multiply sa N and angle theta. So take note nga ang atong problem is naka Maxwells. So therefore, need na to i-convert ang Maxwell to Weber. So we have times 10 raised to negative 8. So 4.44, our F is 60, our N is 240, and our flux per pole is 2.08 raised to times 10 raised to negative 8. Since Maxwell, so dapat i-Weber na to. So calcu, our answer will be 1,330 volts. So therefore, our effective voltage in one phase is 1,330 volts. So let's have another example para masabtan pa. So calculate the average voltage generated in a 6-turn full pitch coil of a 25-cycle alternator if the flux per pole is 7.2 times 10 raised to 5 Maxwell. So first, take note that RMS voltage sa inyuhang machine 1 that 1.11 ang iyahang equivalent sa average value. And take note also that 1 Weber is equal to 1 times 10 raised to negative raised to 8 Maxwell. So to solve for our average voltage, we have our formula. E average is equal to 4 multiply sa tong F and angle phi. So given na to, so naghatag siya og ang atong frequency is 25 cycle and our number of turn is 6 and our angle of phi is 7.2 raised to 5. So multiply sa 10 negative 8. So to solve for our final answer, so let's have here, let's erase. So our average voltage will be 4.32 volts. So this is our final answer for example number 2. So let's have for the coil span. So unsa man ning coil span? So coil span is the distance between the coil sides measured in terms of armature slots. So kaning coil span mao ni atong distance sa atong coils sa atong armature. So we have here natay slots and iyahang coil span. To take note that coil span is always rounded off to the smaller whole number. So formula for coil span, we have slots divided by pole. So memorize this. And for our full pitch, so sa coil span naabot tay full pitch. So ang full pitch is equal to 180 degrees or sa atuang fractional pitch. If the coil span is exactly a whole number, the coil pitch is called full pitch. So giingon, if ang given sa problem is if ang coil span is whole number, so ginatawag na siya og full pitch. If the coil span is less than, then it is called fractional pitch. So kaning fractional pitch if less than siya sa atuang coil span. So take note also that full pitch is equivalent to 180 electrical degrees. And for our pitch factor, if the coil pitch is full pitch, so take note, the generated voltage in both sides of the coil are exactly in phase. So exactly in phase. If fractional pitch is used, the EMFs in the two coil sides are out of phase, which reduces the EMF. Correction for this is done by multiplying the voltage by equation Kp called pitch factor. So Kp is pitch factor. So we have here our formula. So pitch factor is equal to sine P degrees over 2. So kaning P degrees is equal to the span of the coil in electrical degree. So we have in our formula for our P is coil span is slot divided by slots per pole multiply sa atuang 180 degrees. So let's have an example. So calculate the pitch factor for an alternator winding with 36 slots, 4 poles and coil span of 1 to 8. So let's have here. So let's draw for our coil span. So natay coil span. So na siya slot 1. And then we have slot 8. And our coil span ana is coil span from 1 to 8 is 7 slots. So to solve for our pitch factor, so dapat we need to solve first the span of the coil. So let's write span of the coil is equal to slots in span divided by the slots per pole. So atong nakuha na to nga slot span is we have multiply pa sa 180 degrees. So 7 over slot per pole nato is 9. Anong 9 man? So 36 divided by ila ang pole 4 multiply sa 180 degrees. So itong span of the coil is 140 degrees. But ang unknown is ang pitch factor. So therefore, to solve for pitch factor Kp, so sine of slot of span of the coil divided by 2. So nakuha naman nato ang ato ang span of the coil. So we have sine of 140 degrees divided by 2. So our pitch factor is 0.939. So this is our final answer for our pitch factor for an alternator winding. So take note for the formula. And let's have another example para nasabtan. So a 3-phase 4-pole 24 slots alternator has its armature coils short pitch by 1 slot. If its pitch factor will be, so our take note natay given nga number of slots per pole nato. So atong slot is 24, our pole is 4, so we have 6. So take note na sa given coil is short. So note that the coil is short pitch. So unsa maning short pitch by 1 slot. So dapat ang atuang, so it means that the slot span must be 5 slots. So nganong 5 slot man, ma'am? So instead of the full pitch, which is equal to 6 slots. So 6, so minus man siya, so we have 5 slot. So to solve for our pitch factor, we need to solve for span of the coil. So slot span divided by katong slots per pole. So we have multiply sa 180 degrees. So we have 5 over 6 times 180. So span of the coil is 150 degrees. Solving for our pitch factor. So formula, sine of span of the coil divided by 2. So we have sine of 150 degrees divide 2. So our pitch factor is 0.966. So this is our final answer for our pitch factor in our example number 2. And next, so after sa tong pitch factor, we have distribution factor. So when several coils in group are connected in series, the total voltage generated by the group is not equal to the voltage per coil multiplied by the number of coils in group. So it is always less than because the coils are displayed from each other. The factor by which is generated voltage equation must be multiplied because the coils are distributed is called distribution factor. So we have our formula for our distribution factor. So KD is equal to sine multiply sa ato ang N, our alpha divided by 2. So divided by N sine alpha over 2. So kaning alpha ang sa mani. So we have, take note for our formula. So alpha is equal to 180 degrees divided by slots per pole, and our N is slot per pole divided by phase. So let's have an example para mas masabtan nato. So unsa maning alpha? So alpha is the number of electrical degrees between adjacent slots. So let's write here. KD is the distribution factor. So take note in decimal value ang atong factor. And number of slot for N. And our alpha is the number of electrical degrees. So let's have our example for distribution. So calculate the distribution factor of a 36 slot 4-pole 3-phase winding. So first, we need to solve for our number of electrical degrees. So 180 degrees divided by the slots per pole, which is 36 4-pole. So our number of electrical degrees is 20 degrees. And for our number of slots, so N, so slots per pole, we have 36 over 4 divided by the 3-phase. So we have 3-phase. So our number of slots will be 3. And to solve for our KD or the distribution factor, since nakuha na nato ang atoang mga unknown, so we have KD formula, sine of N multiply sa number of electrical degrees divide 2 over N sine of multiply sa atoang number of electrical degrees divide 2. So we have sine of 3 number of holes times 20 degrees divide 2 divided by N nato is 3 sine of 20 degrees over 2. So our final answer for distribution factor is we have 0.96. So dapat ng atong distribution factor must be in decimal value. So this is our final answer. So for our last topic, for our prelim, so we have the corrected voltage of an alternator. So dunina natay generated but karon natay corrected voltage. So for the formula, so combination ni siya. So E is equal to 4.4 multiply sa tong F, multiply sa tong N, and multiply sa tong flux per pole, and our pitch factor and KD factor. So dapat memorize na to kaninga formula. So let's have an example for that. So medyo taas-taas ni siya. So find the no load voltage per phase of a star connected 4-pole 50 Hz alternator from the following given. Flux per pole is 0.12 Weber. Slots per pole per phase is 4. Conductor per slot is 4. 2-layer winding with coil span of 150 degrees. So first, we need to write our for our given. So natay given nga 150 degrees coil span, and we have slot per pole and nato or slot per pole per phase is 4, and we have also so slot per pole, and our flux is 0.12 Weber, and our F is 50 Hertz, and our conductor per slot is 4. First, we need to solve for our pitch factor. So, sine of P divided by 2. So, sine of 150 degrees divide 2. So, our pitch factor will be 0.966. And for our N, na tie slot per pole, we have 4. And our number of electrical degrees, alpha, we have 180 degrees divided by slots per pole. So 180 divided by 4 times 3 is equal to 15 degrees. So kananong i-multiply siya 3 because 3 naka 3 phase ta. So we have after na to sa tong pitch factor, we need to solve for distribution factor. So given na tanan, sine n alpha divide 2 divided by n sine alpha divide 2. So sine of 4 alpha nga 15 degrees divide 2 over 4 sine of 15 degrees over 2. So our distribution factor will be 0.9576. So dapat 4. So na tayo given. So ang number of slots, since naka 3 phase, so we need to solve for our number of slots. We have 4 slots per pole divided by sa tuang phase. Since naka 3 phase times 4 poles atong problem, naghatag siya conductor per slot. So we have 4. So our number of slot will be 48 slots. Nani ato ang number of slots. But for our conductors, so conductor is 4 conductors per slot times the 48 slot na na-solve nato. So therefore atong conductor is 192. And to solve for our number of turns, so number of turns is equal to 1. Turn is equivalent to 2 conductors times ato ang 192 na na-solve conductors. So our number of turns N nato is 96. And our turns per phase is 96 turns divided by 3 phase. So we have 32 turns. So mao ni ato ang number of turns, which is the N. So to substitute data from our corrected voltage, we have E is equal to 4.44 F N, the slots, the flux per pole, pitch factor, and distribution factor. So we have 4.44. Our F is 50 Hertz. Our N is 32. Multiply sa tuang flux na to, which is 0.12 Weber, and sa atong pitch factor nga na-solve 0.966, and our distribution factor nga 0.9576. So our final answer is 788.58 volts per, so kani per phase ni siya. So this is our final answer. So very long, no? So dapat kabalot ta sa tuang formula for corrected voltage of an alternator. So let's proceed to another example para mas ma-master nato. So the following information is given in connection with a Y-connected alternator. Slots is 96, poles is 4, RPM is 1500, turns per coil is 16, flux is 2.58 times 10 raised to 6 lines, coil span is 1 to 20, winding is coiled lap 3 phase. Calculate the generated line-to-line voltage. So natay given mas slots per pole na 96 atong slots. Our pole is 4, therefore 24, and our RPM is 1500, turns per coil is 16, and our flux is 2.58 times 10 raised to 6, and coil span is 1 to 20. So first we need to solve for our coil span of the coil. So we have sine we have coil span divided by slots per pole times 180. So take note sa itong formula. So we have so 1 to 20. So we have 20 minus 1 divided by 24 times 180 degrees. So our span of the coil is 142.5 degrees. To solve for the pitch factor, Kp is equal to sine of P degrees over 2. So sine of 142.5 degrees divided by 2. Our pitch factor will be 0.947. And to solve for our KD, so N is equal to slots per pole per phase. So 24 divide 3, so 3 phase. So we have 8. And for our number of electrical degrees, we have 180 degrees divided by slots per pole. So 180 divided by 24. So our number of electrical degrees is 7.5 degrees. Take note, we have our Kp and we have, and to solve for Kd, since nakuha na nato ang N and our alpha, so Kd is equal to sine of N multiplied to alpha divide 2 divided by N sine alpha 2. So substitute the data. So sine of N is 8 times 7.5 degrees divide 2 divided by N nato is 8 sine of 7.5 degrees over 2. So our distribution factor will be 0.9556. So mani siya, take note. And to solve, so ang unknown sa problem is the generated line. So our F, we need to solve for our F since wala siya naghatag. So Pn over 120, since naghatag siya RPM, so we need to solve. So 4 times 1,500 divide 120. So our frequency will be 50 Hertz. So take note that since not specified, assume that there are 2 coil side per slot. So wala man siya nag-specified, so assume ta na there are 2 coil side per slot. So for simplex winding, and equivalent to 1 coil per slot. So therefore, since natay 96 slots, then there are also 96 coils. So take note nga natay 96 coils. And to solve for our N is equal to 16 turns per coil times 96 coils per phase, 3 phase. So our N will be 512 turns per phase. So to solve for our generated line-to-line voltage, so EP is equal to 4.44. Formula nato KP KD. So we have 44. Our F is 50. Our N is 512. Our flux is 2.58 times 10 raised to Maxwell man siya, so need to convert into Weber. So we have 1 Weber divided by 1 times 10 raised to positive Maxwell. So we have our pitch factor na 0.947 to our distribution factor. So our EP will be 2,653.8 volts. So kani take note per phase ni siya. But ang gipangayo is line-to-line voltage. So EL is equal to square root of 3 EP. So square root of 3 times atong EP per phase ganina. So our line-to-line voltage will be 4,596.5 volts. So this is our final answer. So I hope na nasabtan for our topic this week. So for our prelim number 1, so answer your activity and study in advance para mas masabtan pa. So if you have any question, you can ask me in our Google Classroom. So that would be all. Thank you.